This video is about the ROBOSTALL, a computer-optimized Yama method that follows my previous video, the ROBOFLY. ROBOFLY was an attempt to find not just a better 3-tick Yama cycle, but the best one that could ever be found using computer optimization. We used recursive search to find all possible valid solutions, and then ranked them according to which one is easiest to execute, and then chose that one as ROBOFLY. But hang on a second. If that truly is the case, and ROBOFLY is this theoretical best possible solution, then what is this video about? Didn't we cover everything in the last video? What improvements could possibly be made? Well, since the last video, not only was the bounty that I put out, which I considered impossible, actually solved by someone, but in addition to this, new mechanics have also been discovered which allow us to push this fight to its extreme limits. In this video, I'm going to start off with a quick recap of ROBOFLY and a look at how it fits into the current meta. Next, we'll take a look at how someone was actually able to solve this quote-unquote impossible bounty, and I'll show you the new version of ROBOFLY, ROBOFLY V2, that was created using this solution. And finally, we will build on this using the new mechanics that have been discovered. And not to spoil anything, but these allow us to do some pretty incredible things. Okay, let's start with that quick recap of ROBOFLY and how it fits into the meta. In the last video, we went into depth on the theory behind ROBOFLY and what preferences we wanted to code into the cycle to make it as easy as possible. If you're interested in that, you can check out the first video. However, here, I'll just show you the steps I took to make ROBOFLY. Step 1 is to come up with an attack schedule. On which ticks are you going to be attacking Yama and with which weapons? You do this before even thinking about tiles or movement or anything like that. It's actually a very simple pen and paper exercise where you lay out the ticks of the fight, you lay out Yama's attacks, you lay out the perfect dodges you can hit, and then you simply try and fit in as many Ember Lights as possible into that cycle. Here's what I came up with, and you notice there are some gaps in the cycle where you have to delay ticks because the mechanics just force you to do that, so in those instances, we just add scythes instead of Ember Lights, because if we're burning a tick anyway, might as well do a scythe hit, which is more damage. Once we've finalized our attack schedule, step 2 is to find a path that actually accommodates it. This is where the recursive search comes in. We give our iterator as much information as possible. Basic things like, on ticks where we attack Yama, we have to be stood next to Yama. On ticks where Yama tries to attack us, we need to be stood away from Yama. Stuff like that. Giving our iterator more rules not only avoids low-quality solutions in our final solution set, but it also narrows the search space, which is one of the biggest difficulties when doing a recursive search. Once we've completed step 2, we'll be left with a massive file of all the valid solutions we found. It's pretty cool that you could pick literally any one of these from this list and that would be a valid working solution. But of course, we can only pick one, so step 3, the final step, is to rank them and choose the very best one. We get rid of all the solutions with too many clicks, or clicks that are too clumped together, or tile markers that are too clumped together, and what we're left with are only a few hundred top-tier solutions that I just throw into the visualizer and I look at all the tiles for them, just like you see here, and I pick the best one. So yeah, that's the process. Come up with an attack schedule, find all the paths, and then rank them. This is a really cool and fun way to find solutions, and I'm really proud of how we came up with ROBOFLY, but we gotta ask ourselves, is ROBOFLY actually good? Well, in the last video, we showed how ROBOFLY has a lot of advantages to some of the other methods that are out there. However, in this video, we're only interested in going after the very top of the meta, which is Mulgoat Kirby's reaction-based method. Kirby's method doesn't use a cycle at all, and instead teaches you 6 different sub-cycles and how to identify when to use each one. So how does ROBOFLY currently stack up against the reaction method? ROBOFLY is more consistent, being the same every time, but it also requires a scythe, requires more clicks, and also does less damage. Let's start plotting the damage of all the methods we talk about. Here is the expected damage over time of MonoFly, a slow and easy 4-tick method that we're going to be using as a baseline. We're going to be expressing the damage of new cycles we look at in terms of percentage better than MonoFly. which might seem a little odd. It's to try to be as fair as possible, and I'll have a section at the end where I mention why we do that. Here is the expected damage schedule for ROBOFLY, and it comes in at 6.2% better than MonoFly. And here is the weighted average expected damage of Kirby's method coming in at 8.1%. It's this difference in damage that makes it really hard for someone to justify using ROBOFLY. If they're doing many thousands of Yama kills to get the armor set or to get the pet, they're of course going to want to use the highest damaging method because over time those small time saves add up. But hold on a second, this doesn't make sense, right? How does Kirby's method have more damage if we said earlier that ROBOFLY uses the fastest attack schedule possible? And if Kirby's method is using an even faster attack schedule, then can't we just copy that and build a cycle around whatever attack schedule Kirby's method is using? Well, unfortunately we cannot, and this is the biggest obstacle we're going to try to overcome in this video. ROBOFLY wasn't the fastest attack schedule, but the fastest consistent attack schedule. You see, throughout the boss fight, there are all these opportunities you get to access some really fast subcycle, but a lot of these depend on the fireballs spawning in the right orientation, which is a 50-50 chance. So basically, throughout the Yama boss fight, there are all these opportunities that a reaction-based method can take advantage of, but a cycle-based method has to leave those opportunities on the table every single time to be consistent. An analogy that I'll come back to later in the video is imagine you're giving your friend instructions to get to your house, and along the route there's all these shortcuts that are sometimes open and sometimes not open. A reaction-based method would be like giving your friend a schedule of all of these shortcuts, so no matter the time, they can get to your house in the fastest time possible. While a cycle-based method would be like giving your friend one reliable path that doesn't use any of the shortcuts, even if those shortcuts are available. And herein lies the fundamental advantage that reaction-based methods have over cycle-based methods, and it doesn't seem like this is something we can overcome, right? Well, now that we've discussed how ROBOFLY is found and why it still falls short in the meta, let's get into these new discoveries and what we can do with them. Let's start by talking about the bounty challenge from the last video, why we thought it was impossible, and the clever method someone used to actually solve it. The bounty challenge was to come up with an even higher damaging attack schedule. And here's the one I came up with for ROBOFLY, which I thought was the best possible. So why did I think this was the best one? Well, there are a couple reasons, but the main one is that myself, PortKazard, and GE Challenger, all three of us independently did this exercise and we all came to the same conclusion. So then, how was the player Muffyn able to come up with an even better damage cycle? What did Muffyn see that we missed? Well, our mistake was ensuring we got every single one of the perfect dodges. Muffyn cleverly experimented with skipping some of the perfect dodges, which is very counterintuitive because you actually add a tick when you do this. But Muffyn was able to make up for this elsewhere in the cycle and actually make the entire cycle more damaging. Here is Muffyn's attack schedule, and by the way, Muffyn contributed to a ton of stuff in this video, so thanks so much, and 250 mil bounty, which was 50 mil from myself, 200 mil from PortKazard, well earned. In fact, this cycle is so good and such an improvement that I was a little salty, and let me tell you why. See, when I put out the bounty, I assumed that the solution was going to be some crazy complicated thing that wasn't worth doing, but would still be really interesting to learn about. I did not expect Muffyn's solution, which, because it skips some of the perfect dodges, it's actually easier. It's literally higher damaging and easier, which means it renders ROBOFLY obsolete. This was a bit of a tough pill to swallow, but that's okay, we'll move on, and we already have the program, so we can just rerun, follow the same method as I discussed, and create ROBOFLY V2. Now, the first thing I wanted to do was confirm that Muffyn's solution actually was the best one possible. I didn't want to make the same mistake again, so I built a second recursive search algorithm purely for this purpose. After it searched through all 200 million possible combinations, it confirmed that Muffyn's is indeed the fastest attack schedule, at least for now before we introduce those new mechanics. I started to redo this process, and here's the solution I came up with, but I never actually executed this one in-game because it's not the one we're going to use. If we want the best cycle possible, we need to question some fundamental aspects of what we're doing, and here we question the Scythe. A single Scythe hit only does 7% more damage against Yama than a single Emberlight hit, so it's really not that much better. The idea before, however, was, hey, we have this fundamental disadvantage against the reaction-based method, we need all the damage we can get, so whenever there's a 1-tick gap in our cycle, let's just swap out a 4-tick Ember for a 5-tick Scythe and get a little more damage. But how much trouble is it actually worth going to get these Scythe hits in? Especially when you consider the fast Scythes that are in our cycle. In order to land these, you need to do a weapon switch and hit a perfect fireball dodge in order to turn it from a 5-tick Scythe to a 4-tick Scythe. All of this could just easily be replaced by a 4-tick Emberlight, which fine is slightly less damage, but it is much, much easier. So let's take away all the fast Scythes from our cycle and replace them with regular Emberlights. And after we do this, we're not left with many more Scythes, so let's just remove these as well and do an Emberlight only cycle for ROBOFLY V2. This was one of the most requested things, by the way, a lot of people mentioning how they don't have a Scythe or they only have the Emberlight or Arclight. Well, if that's the case, this is the cycle for you. Here are the tile markers for ROBOFLY V2, and they're read in the same way as the last video. Here's a quick diagram explaining how to read and follow them. You just do right side, left side, left side, right side, left side, and repeat. Let's take a look at a duo kill using ROBOFLY V2. Overall, ROBOFLY V2 is a direct upgrade to ROBOFLY V1, being more damage and easier. I would even say it somewhat has the feel of a 4-tick cycle, which is really what we were going for. Let's see how it stacks up against our other methods. ROBOFLY V2 comes in at 6.5%. We can also try and quantify how easy the cycle is by counting clicks, dodges, and weapon switches required. And you can see that it beats out ROBOFLY V1 in all of these categories. Let's take a look at the solo version of ROBOFLY V2, which also has to take care of the orbs and the more complex waves later in the cycle. Here are the tiles, and let's take a look at a full kill example. I think we can say that ROBOFLY V2 is a worthy alternative to Kirby's method if you prefer a cycle-based method. However, we can't ignore that it's still 1.5% less damage. Let's see what we can do about this by getting into the new mechanics. By turning yourself into an egg at the precise moment, you can access new Yama subcycles that were never possible before. This is done using the Easter egg ring, a cosmetic item that at first glance doesn't do a whole lot. It doesn't protect you from damage, it doesn't stop Yama from attacking you. but it will cause Yama to wait an extra tick to do one of his fireball attacks, stalling one fireball attack by 1 tick. While this might seem like a minor change, it actually allows us to shuffle around one of the core restrictions that we've had to work around this whole time, unlocking many new possibilities. This is the idea behind ROBOSTALL, but it also makes things much more complicated. We now have exponentially more options. We have to consider every possible way you can shuffle these perfect dodges around. However, all this complexity is well worth it because there's a lot of potential with using this stall tech. If we're going to fully explore this, we also need to upgrade the iterator. I'll just quickly tell you the 3 most impactful changes. The biggest is we use a node-based approach, which is much faster than the old list-based approach. Our fail conditions now don't check the entire list every time and only check as many nodes as is absolutely necessary. And as you can see, we have proper split and resolution nodes for handling these split paths. Okay, so that's how we've made our iterator over 100 times faster. But remember, this iterator is for step 2 of the process, and step 1 is to first find a attack schedule. Remember, we already made a program that solves for the best attack schedule, or step 1, so let's upgrade this one as well and add stalling to find the best attack schedule using this stall tech. Okay, so now we've implemented this process, let's take a look at the results. Something really strange is going on. We get our usual results with embers and fast embers and scythes and fast scythes, but we also get extremely high damaging cycles with fast scythes. What is going on here to get such a strange output, and what even is a fast scythe? Basically, now that we can shift these perfect dodge ticks around, you can put 2 of them close enough together that a scythe attack can get sped up twice from 2 different perfect dodges. But surely this isn't actually how it works in-game, right? Surely this is just a quirk of the program. The scythe is the heaviest hitting slow weapon in the game, and this would mean it would be attacking as fast as a swift blade. In fact, if this turns out to be possible, this would be the highest damaging single non-special attack in the entire game. We started with 4 ticking, we've optimized 3 ticking, but is 2 ticking really possible? Well, there's only one way to find out. We ran the program, found a path, and let's give it a shot. Now the 2 ticking is going to be pretty fast, so if it does work, here's what you'll see. After the special attack, the character will turn into an egg. Move 1 tile to set the next fireball, move 2 tiles to prepare for the fast scythe, do the first attack while dodging, prepare for the second dodge, do the second dodge, and then attempt to attack a second time. If it works, we'll see that attack go through. If not, the character will awkwardly stand there and then just move to the next part of the cycle. Okay, with that in mind, let's take a look at what might be the first case of 2 ticking a scythe. And there it is, the first recorded fast scythe, the highest DPSing single normal attack in the whole game. Also, can we take a moment to appreciate the super cool 360 that your character does while doing the wave skip? Overall, extremely happy with these results, and we can now say that 2 ticking is indeed possible. Before we compare the damage and difficulty of this cycle, I did mess up the first time around, which is why I sped up the first half, so here's a full clip with no mistakes. Now, I did realize after getting these clips that if you replace the AGS special attack with the other AGS, the Ancient God Sword, that special attack actually has 30% more expected damage, and it heals you, so it's really a no-brainer, and when we calculate DPS, I'm going to be doing it based on that. Okay, let's take a look at how this cycle, which I'm calling the TRISCYFLY, stacks up against our other cycles. In terms of damage, it comes in at 7.5%, which is really amazing. However, we're still below Kirby's method. We are painfully close, and if we could get a method that's just 0.1 or 0.2% more DPS, we could make a good argument that it could be a meta cycle. But definitely not this one. Despite the high damage, it's just too hard to execute. Not only is this how it ranks compared to the other ones, but it requires multiple instances of clicking twice in the same tick, which is really difficult to do, and all the other cycles avoid that. So as cool as the TRISCYFLY is, we need to keep searching, ideally for a solution that doesn't require us to do an AGS into 2-tick Scythe stall 360 wave skip. I'll spare you the details, but I worked with Muffyn to try some things that seemed very promising with stall tech. However, after we tried everything we could possibly think of, nothing seemed to work. We got very close many times, it was very frustrating, and we just couldn't get it to work. The dream of ROBOSTALL had to be put on hold for now, because there's actually a second new mechanic that was discovered since the last video, and we're going to try and accomplish our goals with that instead. Let's talk about the new mechanic, Chase Tech. Here's how Chase Tech works. Normally, Yama doesn't move in Phase 3. However, for some strange reason, if you use a Scorching Bow special attack on Yama in Phase 3, then 20 ticks later, Yama will start to follow you for the remainder of the fight. It seems that what's going on here is the Scorching Bow special attack, which binds demons in place for 20 ticks, is overwriting whatever programming was used to make Yama stay in place for Phase 3. So instead of that holding Yama in place, it's the Scorching Bow special attack holding Yama in place, and that expires after 20 ticks. So basically, you can switch the fight from Yama staying still to Yama following you around. But how can we take advantage of this? Does this really offer any opportunities? Because normally, this is one of the worst things you could do. It would make the fight much harder. In fact, so much so that those of you who have done the challenge contracts know that the hardest one is sensory clouding, and it's as difficult as it is because Yama chases you. That's the gimmick of the contract. So why would we ever do this to ourselves willingly? And let's take a second to just think about the crazy complexity here. You have to dodge Yama's melee attacks, skip the waves, hit the perfect fireballs, while still getting max DPS, all while Yama is chasing you. This would be super hard to do reactively. However, it's really not a big issue for us because we're using pre-computed solutions anyway. It should be the same as normal. You click the tile marker and then you click the boss, and you just follow whatever cycle we come up with. All that complexity is figured out for us beforehand and just reduced to a bunch of tile markers. We're going to be calling this solution the ROBOKITE, and let's jump right into how we're going to solve it. Solving a fight with Chase Tech is fundamentally different than what we've done before, so here are some key considerations we're going to have to think about when coming up with ROBOKITE. Number 1 is waiting ticks. As nice as it was in our other cycles to have your character constantly moving so you always anticipate when you're going to click next, we just can't have this when Yama is chasing us. But that's actually okay, because we're still going to make sure there's always something else motivating our next click. There's always something to look at, to watch, to tell you exactly when the timing is. Consideration number 2 is the same movement for each set of fireballs. What I mean by this is in each cycle, you're going to have to deal with the fireballs 3 times. So, wouldn't it be nice if each time you had to deal with those fireballs, it was just the same maneuver every time, just in a different part of the map? Having these repeated sections like this should make things a lot easier overall. We were having a very hard time solving for this manually with a lot of really ugly looking solutions, but once again, by turning to computers, I was able to come up with a much better solution. This shape right here. Look how much nicer that looks. And also, it works on the side of Yama, not just the corner, which was pretty surprising and offers a lot of flexibility for us to make our final solution much, much easier. Okay, now that we solved consideration number 2, we need to look for consideration number 3, which is the waves, and this is really tricky. Here's a visualization showing how the waves move throughout the arena. This wasn't much of a problem before because the computer would just automatically solve for a path that skips all the waves. However, with this nice simple pattern we've come up with, there's just too many waiting ticks, and the waves seem to hit you no matter what. You need to be moving around a lot to dodge the waves, and we're just not moving around, so maybe we won't get to use this nice simple fireball solve after all. However, there's actually a solution to this, and it's simply to place each shape in calm areas. You can see through this wave simulation that there are areas of the map that don't experience waves for quite a few ticks, and we can just move Yama into those positions so that when we do our fireball skips, we're just not dealing with the waves at all, and it actually works out really nicely. Okay, with all those considerations in mind, let's use computer optimization once again to solve for ROBOKITE. As the cycle came together, I started to realize the actual potential this tech had. And when I saw what the final solution allowed us to do, I almost couldn't believe my eyes. This is ROBOKITE, and it is absolutely insane. Let's just jump into it and take a look at a full example kill with ROBOKITE, and then I'll show you why this is such an unbelievable breakthrough. It might not be immediately obvious, but this is the best cycle, and it's the one we've been looking for. There are a lot of great attributes about this cycle I could point to, such as how it can be done with Ember Light only, how it doesn't require many clicks, how all of the clicks are motivated by your player attacking, so it's always easy to know when to click to the next tile. But to really understand why this cycle shines, let's take a look at the damage. This has been a long journey, and we have been trying to chase the damage of Kirby's reaction-based method. We developed ROBOFLY at 6.2%. We used Muffyn's improved damage cycle to develop ROBOFLY V2, an easier version that does 6.5%. We used new mechanics, stall tech, to make TRISCYFLY with the first 2 ticking at 7.5%, so close to Kirby's. If we could just get 0.1% over Kirby's, it would be enough to say, hey, this is the method that will technically save you the most time. This has a definite place in the meta. So where does ROBOKITE rank on this list? ROBOKITE comes in at 14%. Yeah, that's right, 14%. This is the fastest damaging Yama method ever discovered. Just to fully cement how much of a breakthrough this is, even the current world record for Yama doesn't get attacks in as fast as ROBOKITE does. So yes, that does mean a new world record is very easily on the table. You could just do the exact same thing the current world record does, but swap in this method for phase 3 and you'll have a good chance. But how is it getting 14% damage? Didn't I say at the start of the video that reaction-based methods had a fundamental advantage where they should always have more damage than cycles? Recall that analogy I gave about giving your friend directions to your house, where a cycle-based method is one consistent path, and a reaction-based method lets you take advantage of these shortcuts as they're made available. So what's going on here? Well, it's pretty incredible. Here's what's actually been happening with those 50-50 shortcuts that I've been talking about. When you attack Yama on the same tick that the fireballs start to fall, one of two things can happen. You can see on the left, the fireballs fall vertically, so here are the perfect dodge tiles, and you can easily hit the perfect dodge and attack on the same tick. But on the right, if the fireballs spawn this way, then you can't perfect dodge and attack on the same tick. It's one or the other. This is what I've been talking about when I mentioned how Kirby's reaction method can take advantage of these 50-50 opportunities. In Kirby's method, where he shows you the 6 different sub-cycles, he calls one of these really great cycles the God cycle, which should tell you how good it is. But that's not even the best one. The best one he calls the Ultra God cycle, which shows it is really what you want, but it is very rare to happen and might only happen once a fight if you're lucky. But going back to our fireball diagram, if Yama is chasing us, then we actually can attack Yama in this position as well, because we can just drag Yama towards us, which means we can get the same extra shortcut regardless of how the fireballs spawn, which takes away all of these 50-50s, they're gone. We don't need to worry about them. Our 50-50s are now 100%. Here's a table showing all the different things that could happen when doing Kirby's method and the damage you get for each of these scenarios. We used this to take a weighted average, and that's how we came up with the 8.1%. Sometimes you get a bunch of fast cycles over here, sometimes you get a bunch of slow cycles over here. It's all about how does it average out over time. With ROBOFLY, we had to accept that we were going to leave out all the shortcuts, which means we were essentially always getting this damage cycle, and we were trying our very best to inch out every little bit more damage we could get with the scythe to sort of move from here to over here, but it only helped so much. With ROBOKITE, however, and getting rid of these 50-50s, we are effectively forcing a continuous string of Ultra God cycles every single time. To have this same thing happen with Kirby's method, it would be a 1 in 192 chance, and we get it every single time with ROBOKITE, and that's how it gets so much damage. If we go back to our analogy of giving your friend directions, ROBOFLY would be like giving them the slow, consistent path that ignores all the shortcuts. Kirby's reaction method would be like giving your friend a schedule of all the shortcuts so they can know which ones are open at this time and use those ones. And ROBOKITE would be like giving your friend a rocket launcher where they can just blast open every single shortcut no matter what. In conclusion, I think we've added a lot of great, valuable alternatives to the meta for Yama. Previously, if you wanted more damage than 4-ticking, you had to do Kirby's reaction method or Portkazard's no-fly. We added the ROBOFLY, an experimental method that fell short of the meta but still showed us what was possible. We added the ROBOFLY V2, a much easier, higher damaging version that could even be done with an arc light. This is the one I would recommend for most people. We added the TRISCYFLY, a powerful yet impractical method that showed off the power of 2-ticking. And finally, we added the ROBOKITE, the undisputed highest damaging method in the whole game. I hope you enjoyed these videos. It's been a really fun journey, and this is going to be my last video on computer optimized Yama. However, if a new boss comes out that also could benefit from computer optimization, then I will definitely be trying to apply these same techniques. Like the last video, I'll be doing an epilogue to wrap things up, and here are the questions I'll be discussing in this epilogue. Can we 2-tick with an Emberlight? When we went over stall tech and the TRISCYFLY method, you might have thought it was a little strange that I call it 2-ticking when it's actually a scythe that takes 3 ticks. Well, we've been referring to 3-ticking as an Emberlight or a scythe that gets a speed up, so 3-ticking is a 3-tick Emberlight or a 4-tick scythe, so it just makes sense that 2-ticking is a 2-tick Emberlight or a 3-tick scythe. It's just an easier definition to use, however it does feel a little bit incomplete if we don't have an example of a 2-tick Emberlight, so is that possible? Unfortunately, it appears the answer is no. Here's a setup where it should have worked, but it just didn't, which leads me to believe there's some kind of cap, or maybe you can't get 2 dodges 1 tick apart. Can we do 1-ticking? Well, that depends what you mean by 1-ticking. If you mean getting 3 boulder hits in the same attack, well, that's only possible with a super slow weapon, a 9-tick weapon. There's only one 9-tick weapon in the game, it's the dark bow, and that's only if you set it to accurate or long range, so technically yes, you could shoot the dark bow on long range in 6 ticks instead of 9. If you call that 1-ticking, go ahead, but I don't think it counts. What's the most we can stall the fireballs? We can stall all of them to fall at the same time, like so. There's no use for this, but it's kind of funny. Is Kirby's method still useful? Yes, absolutely. I hope I didn't give the impression that Kirby's method is now obsolete, but it is no longer the #1 highest damaging method, so if you want the #1 highest damaging method, then ROBOKITE is what you want to do. Kirby's method is still great for recovery if you break cycle, and it's also arguably easier than ROBOKITE depending on what you find to be easy, and Kirby's method is really useful for the contracts. I imagine Kirby's method will continue to be the most popular one because I think it is still the best balance between ease and damage. But between ROBOFLY V2 and ROBOKITE, I think that we have contributed enough to the meta that there are some real alternatives, and yes, if you want the highest damaging method, we have replaced Kirby's method for that specific purpose. Why do we calculate the damage this way? The reason we calculated damage this way is pretty straightforward. If you're comparing 2 cycles, it's always going to depend where you choose the cutoff point, so instead, doing time to kill simulations is much more accurate. Here are all the individual time to kill distributions for each method. What happened to ROBOSTALL? So it might seem kind of weird that we just abandoned stall tech halfway through, and the reason is we just couldn't get it to work. I don't think it can create what ROBOKITE can create, unfortunately. If we were to make ROBOSTALL, it would be 6 expected damage higher than ROBOKITE, so not a huge improvement, but it would be a little bit better. In my opinion, stall tech is the coolest tech here, and it's what I spent the most time on this video trying to get to work, and so that's why it's still the title of the video. Is this the best DPS we can get? Pretty much, yeah. We're now really just limited by Yama's attack cycle, and not even the fireballs anymore. This is basically as good as it gets. I mean, it's all embers, all the perfect dodges, and only 1 swift blade, but that's necessary. We have not been able to find a way to delay Yama's actual attacks, so this is fundamentally as good as it gets. What else can we computer optimize in the game? I will look into this one day. I might just make a video quickly talking about all the things in the game that could be computer optimized and all the things that wouldn't benefit from it. But in general, for something to benefit from computer optimization, there has to be cycle methods for it, and they have to be so complex that they're not easy to solve by yourself. Yama was honestly really unique in this way, and I hope we see something like this again in the future. And that brings us to the end of the video. Thanks for watching.